So we are looking at this same graph, but I'm going to talk about symmetry in behavior, average rate of change, and domain and range. Sometimes polynomial graphs are symmetrical about a line, for example, about the y-axis or about another line like x equals -1 or x equals -2. But this particular graph has no symmetry. The end behavior, as we look to the left, this function goes up. So we say f of x approaches positive infinity. And as we look to the right, this graph goes up. So as x approaches infinity, the function approaches positive infinity. Now the average rate of change sounds really intimidating, but all that really means is slope. We are finding the slope between 2 points, between the negative x-intercept, which is -2, 0, and the y-intercept, which is 0, -16. So I wrote those 2 points down, and we are going to find the slope. So that is y2 minus y1 over x2 minus x1. So on top I have -16. On the bottom I have 2. And -16 divided by 2 is -8. So my average rate of change between those 2 points is -8. The domain for most polynomials is all real numbers because it goes forever to the left and forever to the right. So you can either write out all real numbers. You can actually write that fancy R that you may have written in previous classes. But a really fancy way to write it is -infinity to infinity. The range, this graph only goes from -27 up. So y is greater than or equal to -27. And the fancy pants way of writing that is bracket -27 to infinity.